if you're removing contamination from parts before they go. If you don't get it right in those first process steps, then you've kind of at that point, you're not going to get good results in all the tanks where you actually make money, where you're putting value to the part. So, if you get the first steps right, everything else is going to be bad. So, you can't fix that. You can't fix those problems downstream if you don't get them right at the beginning. So it's kind of common sense, but
Mike, you just brought up something that I also think is an important thing to touch on here, and that is people think about adhesion, coating, sealing, plating as the discrete point when you apply that chemistry to your substrate, right? So people think like, okay, I'm adding value because I applied paint to my part. That is my value, right? That's where I'm making money doing that.
They're right.
However,
that's their service. That's what they're doing. Right. Otherwise, because that's a performance. When you plate a part, when you put a powder coat on a part, when you anodize a part, all those things are to give the part some type of performance characteristic, whether it's corrosion resistance or decorative appearance or some other functionality that you need. That's what they're getting paid to do, right? Everything before that is a requirement, a have to do,
right?
And to get it right.
Yeah. And the thing that I think is so important to stress for folks, and it's one of the reasons that failure occurs in every industry, every day, there is product failure happening somewhere. All right. And I'm sorry, guys, this thing is clicking around on me. And one of the things that I think is important to remember is that it's a system. There's multiple inputs that result in the value that you're putting into the part. I remember talking to it's just called like an aftermarket painter of trucks. Think about like, an Amazon delivery truck. And talking to them, they were like, we're a painting business. Like that's what we do. We paint things. But in their minds, all the value happens when that color, that liquid color coating goes onto the substrate. They think cleaning is a have to do. But there's three inputs to making painting work or bonding work. It's the chemistry of the paint that I'm applying, it's the way I'm applying it, and it's the substrate I'm applying it to. All three of those things combined are what allow you to create the value of what it is you're trying to do. And I think it leads perfectly into this slide here.
Yeah, the best powder coat in the world is not going to stick to an oily part.
Absolutely.
Right.
Absolutely.
Yeah, so we talk about cleaning. So, I go in, we do a lot. It's one of our largest areas, and people just say, well, it's just soap, right, Mike? It's just soap. Like we're just soaking it in soap. And it's not that simple. So, when you look at any kind of metal finishing process and so I call it the tip of the spear. It's the first thing you do, right? You got to clean the parts, whatever the soil is, whether it's oils, coolants, it could be particle, it doesn't really matter. There's always a contamination on the surface. And if you look at a typical metal finishing operation, the total chemistry cost to process a part is somewhere in the around 10% range, right? So, that chemistry cost compared to labor and everything else is a small part of your total operation anyway, right? So it's not a big line item. And then when you look up at just cleaning and the surface prep part, that's even a much smaller percentage. So your money's tied up in equipment, labor, other things. It's not really tied up in these steps where you're preparing things. So what we try to teach people is why, it's not a big cost, so don't skimp on it. And if you clean parts poorly or don't prepare the surface poorly, then that's when you're going to see a big cost. Because for example, if you try to plate a piece of aluminum, say with electroless nickel, I'm going to use that expensive process, right? If that piece of aluminum is not prepared properly, when you get that EN tank and that's scrap. Like we're not going to be able to go back and fix that part. So, you know,
yeah, there's no rework, right? Like you're not
no rework.
in those
in
processes.
Some cases, there are process rework, but if you powder coat parts and the paint doesn't adhere and you ship the part to a customer, I can tell you we had a customer years ago that brought us in to fix a problem. They were powder coating the big electrical boxes that go at like a Walmart or hospital. It's where the power comes in the facility. These are big steel, you know, electrical. It's where the power comes in. The paint, the powder coat, was peeling off these boxes, and you know what happens then is that because they were made of steel, they'll get corrosion. They had to shut these facilities down. I won't say who the company was, but the company that was making these had to pay millions of dollars in lost revenue to these retailers and hospitals because they had to shut down to fix the problem. So, you know, it's a big deal. So yeah, all these things are just cost and pain points. It's loss of productivity, trying to, you know, if you don't clean parts and you drag oil or contaminants, say, into a plating line and you have to rebuild that plating tank, that's a huge expense compared to the cost of the cleaning process. So, you know, it's not just whether the parts are bad, but what do you do to all the other tanks downstream in your process line that you've now contaminated, and now you can't make anything good because they're contaminated. So again, don't skimp on what we consider one of the easiest steps in the process.
And also, I mean, it's simply, you know, whether I'm bonding a wind turbine that happens to be exploding off the coast of Nantucket or whatever was just happening a couple weeks ago, or I'm doing a nickel plating process. I mean, people think of cleaning as almost like a necessary evil, or just surface preparation. Let's just say surface preparation, like a necessary evil. It's not. It's literally part
of the whole process.
You've got to look at it holistically. If you've ever struggled with random rework or failure that's been hard to pinpoint where that happened, you know, 90% of all the failures we ever see is due to poor surface preparation.